All right, so the next and final question is just a math problem with Taylor series. I figure I'd go ahead and go through it. With our function f of x equaling tangent of x. And the first thing to do if you want to use the Taylor series is take a whole bunch of derivatives. In this case, it says up to n equals 3. The first 4 terms. Kind of a big highlight, but whatever. So we need to take 3 derivatives. Hopefully you remember what the derivative of tangent is. Secant squared. Now the way that we find second derivative takes a little bit more work. We want to find the derivative with respect to x of secant squared. I'm going to just break that up into 2 secants. I'm just going to rewrite it. And from here we can use a product rule. The derivative of the first is secant. So this is, the derivative of this is secant tangent times the second, which is secant. So secant squared x tangent x. And then if we take the derivative of this, that's again going to be secant tangent, times this secant is secant squared. So in other words, 2 secant squared x tangent x. And now we need the third derivative. I'm just going to rewrite this as this. I'm going to factor out the 2. It's a constant, so because of linearity, we can factor that out. Of secant squared x tangent x. Again, product rule. So the derivative of the first is secant squared. And we did that here, right? And we found that the derivative was this. So this times the first, or the second, which is tangent. So that's going to be 2 secant squared of x. Tangent x times that second tangent x is tangent squared of x. Plus the first, which is secant squared, this is the first, times the derivative of the second. Well, the derivative of tangent is again secant squared. So that's secant to the 4th x. And just distributing that 2 out, you'll get 2 secant to the 4th x plus 4 secant squared x tangent squared x. So we have all our derivatives. Now we just need to follow the Taylor series, where your function is the sum from n equals 0 to infinity of f of n, fn, n being the derivative, times x minus x naught to the nth power over n factorial. So the first one, we just evaluate the function. In other words, tangent of 0, x to the 0 power over 0 factorial plus secant squared 0, x to the first power over 1 factorial plus, what are you getting into, dog? Leave that alone. Plus the second derivative is 2 secant squared 0 tangent 0 x squared over 2 factorial plus the last one we found, which is 2 secant to the 4th, not x, 0, x naught is 0, plus 4 secant squared 0 tangent squared 0 x cubed over 3 factorial. Tangent of 0 is 0 because that's sine over sine. So that's 0. This is 0. This term is 0. So what are we left with? This is just 1, so that's just going to be x plus, let's see, 2 over 3 factorial. 3 factorial is 6, so that's a third x cubed plus 1/3 x cubed. And this is approximately tangent of x. These are the Taylor polynomials for tangent x. That's all there is to it. So if you can take derivatives and follow the series here, then you're okay. And if you've never seen Taylor's series, then it's pretty important. It was in the last homework I didn't get to upload. But yeah, it's not too bad. It's pretty